Yeah. Okay. So now, today we are going to do formation of images by mirrors, and if possible then we'll move on to lenses also. Okay, Rohin, come over here. Come here. See, now Rohin claims that he can see with only one eye. He doesn't need the other eye. Remove that specs. Keep it over there. Come. Put your hand on one eye properly. Palm. Good. Okay. Now this in one go you have to touch the tip. Okay. In one go. Yeah, do it. Not sideways. You have to touch the tip. Not sideways. Not sideways. So he doesn't require the other eye. Yeah, do it, man. Do it. Okay, do again.
He has power.
The point is. Yeah, the point is not on the point. Anyways, even though he knows the size of the object, if the object was unknown to him, he won't even come to know that this is here or there. He won't be able to make that distance also. Since he knows it's a pen, automatically the brain is registering that he is seeing the pen this big, it must be this far away. Okay? And hence he is able to go almost near to the object. Suppose I bring a random object, the size of which he doesn't know, and I don't keep it in my hand because the size of my hand he knows. So, he is able to go about near to the object, not exactly at the object, because he knows the size. For unknown things, he won't be able to know how far it is. See what happens. This is your eye. Okay, beautiful eye, eyelashes. Now, this is your eye. This is the object. Light is coming from the object. Light may be coming due to reflection from the object, or the object may have its own light, like a bulb or a tube light. Okay, it is reflecting light and it is going to the eye. What does the eye think? The eye will only see that the ray is coming in what direction. It doesn't know that the ray has traveled like this and went into the eye or there. It goes into the eye. The eye thinks that the object may be in this line anywhere. Okay? It doesn't know it is here, there. The brain tells that if you are seeing a pen, it must be somewhere around here. The eye cannot make out that thing. Get the point? Now, this is your other eye, suppose. And light is coming from the object to the other eye also. This eye will think that the object is anywhere in this line. Now both the eyes are sending the signal to the same brain, right? For most of you. So the brain will interpret that it must be right over there. Because this eye is telling this line, that eye is telling that line, and it must be over there. Getting the point? Is it clear? Many animals, when the eyes are this side and that side, they have to run. They will keep the face on one side and run. Okay? Yeah, both the eyes register two different worlds, man. It could have been very well that the object was not here at all. The object was somewhere over here, and by using mirrors or something, one ray got reflected and went to this eye, and the other ray got reflected and went to that eye. I kept a mirror like this over here, and I kept a mirror like this over there. Getting the point? Now, the eye doesn't know that the mirror is kept. Suppose it is a very clean mirror. Eye doesn't know the mirror is kept. What would this eye think? That the object is here, and that would think it is in this line, and the brain will feel that the object is over there. Such a image is called your non-real virtual images. Okay? It is not actually there. If you go and hold it, the light rays are also not coming over there. You are not interrupting anything. Okay? Even when you keep your hand over there, this light will still go to the eye, that light will still go to the eye. Get the point? It is same as if I have a mirror in front of me, I am seeing my face, somebody does something at the back of the mirror, does it change anything? No. Something is at the back of the mirror, doesn't change anything. Get the point? So if you keep anything on the back of the mirror, that is not going to change the fact that the eyes will think that the image is over there. Is it clear? Is it clear? So to get the exact position of any object or image, you need at least two rays. One ray can never tell you the actual position of the object. Okay. So last year you were doing for a plane mirror. A point object is there. How to find the image? You will follow the laws of reflection. What is the laws of reflection? So it says that the incident ray, the reflected ray and the normal lie in the same plane. Okay, what is the big deal about this law?
But it means they have to be in the same line.
What? What do you mean by same plane?
As in, like, they have to be on that mirror. They have
Give
to
me
be
a
on
pen.
the same mirror.
Give me a pen.
On the same surface.
They have to be on the same surface.
On the same surface.
Like on that mirror, like in the depth. You've drawn the
Mirror is here.
Exactly. So all three of them have to be on that mirror.
On the mirror.
Or they have to come off the mirror.
See, suppose there is a mirror over here. Okay? This is the incident light. This is the incident light falling on the mirror, and this is your reflected light. Get the point? Where is the normal? Normal is, what do you mean by normal? 90 degree to the plane of reflection where the mirror is. So you will first draw the normal. Incident ray is like this. Now you will draw the plane containing the incident ray and the normal. What do you mean by the plane? Suppose this one is your normal, this pen is your normal, this is the incident ray. Okay. So this is the plane. This is called the plane. Okay. The paper which will contain both the lines. If I make the incident ray like this, then this is the plane. Okay. No, that is the mirror. This is the plane which is containing the normal and the incident light. Now if this is the incident light, this is the normal, the reflected light has to be in the same plane. That means the reflected light can't go like this, can't go like that, it will go in the same plane. Getting the point? I have a third pen. So these three are in the same plane. Any two rays would as such be in a single plane. Two rays can be contained in a plane. But the third ray also being in the same plane is the law. Getting the point? Normal is not a ray. It's an imaginary line what you draw perpendicular to the surface. Okay. If this is the surface, since the camera is not over there, I have to make the surface over here. If this is the surface, okay, then this is normal, which is 90 degree from all sides. This angle is 90 degree, that angle is 90 degree, that angle is 90 degree. This is not normal to the plane. This is not normal to the plane. So this is called normal at the point. So this is the normal. Now, if this is the incident ray and that is the normal, reflected ray cannot be this, cannot be that. So the law which says that the angle of incidence is equal to the angle of reflection is not complete. I have made the angle same here also, but that is not, this is not the way it will reflect. First of all, it will reflect in the same plane, and it will reflect in which angle? At the same angle. Okay, get the point? Even for refraction, it has to be in the same plane, first of all, and then what is the angle is given by the second statement of the law. Get the point? So got the point? What do you mean by plane? Okay, now just for revision, if you have to draw the image of this object, what will you do? First of all, at least two rays are required. So two rays in any direction you can take, any random direction, whatever you feel like. Okay, but mostly it is easy to take a ray which is absolutely normal. So we will draw that later on. First I'll take any random ray. This is a random ray. How will it reflect? Draw the normal. Okay, this is your, and this is your reflected ray, this is the incident ray, this is the normal. Will it tell you where the object is, where the image is? No, one is not good enough. It will just tell you, if your eye is over here, then it will just tell that it is in this line somewhere. Okay, the other ray, what will you draw? Another slant ray, anywhere. So maybe this one. Then this will also reflect using the angle of, following the laws of reflection, and it will go back like this. It will go to another eye, and now we have a definite image wherever they meet. If they don't meet anywhere, then we will say that the image is formed at infinity. Okay, so if we draw back, then this is your image, this is your object. Get the point? This is virtual because these are not made by actual rays. You can make them as dashed ones, but it is not made by actual rays. It is made by imaginary rays. It is an extension of the rays. So this is how you are going to draw your images in curved mirrors also. The same funda you will follow. Okay. So first I'll give you a curved one and let me see how you draw it, whether you get it right or not. Then we'll use some rules to draw it. Okay. Now the easier ray to draw in such case was what? Even if I draw a ray like this, say over here, it will reflect in such a way that this angle is equal to that angle, and this will also extend back to the same point. That means if you have an object, image always be formed over here. From where you are looking, that doesn't change the position of the object. Okay, get the point? Is it clear? If the camera is kept over here and there is a mirror, the image of the camera would be this much distance behind the mirror, whether I look from here or I look from here or I look from anywhere. The location of the image is not going to change. Okay, the ray which is helping me look at the image, that is going to change. If I am looking from here, most probably a ray will come over here, strike and go to my eye, and that will help me look at the image. If I am looking from here, and the ray will come like this, strike my eye, and I will be able to look at the image. So one ray I will always try to draw, which is the easiest one. A normal comes back normally, goes to one of the eye, extended back, it will also be over there. Okay, using congruent triangles you can easily prove that this distance is equal to that distance. Why? Let us just do it. This is 90 degree, that is 90 degree. I don't know the distance yet, I have to prove that. Okay, this angle is suppose theta, then this angle is also theta using law of reflection. Okay, if this is theta, then that is theta. This line is parallel to that line. This is theta, that is theta. And if this is theta, this is also theta. They are alternate angles. Okay, any doubt? So this angle equal to that angle equal to that angle. Obviously this angle also equal to that angle. All angles are same, and this side is common. So it's a congruent triangle, hence this distance will be equal to that distance. Okay. So now let us go on to what is there this year. Now curved mirrors. Okay, there are many types of curved mirror. Only two types we are going to do this year. One is concave and other one is convex. What do you mean by these curved mirrors, convex and concave? Look at this. Look at this. Somebody raise your hand and tell me whether this is convex. This side is the shiny side, it is reflecting the light. Whether it is a convex mirror or a concave mirror or this is neither concave nor convex mirror. Okay, it's a very common mistake. What you people do is, a part of a cylinder is not a convex mirror. Okay, when I draw on the board, we only draw the 2D of the 3D. You feel as if it is this thing what we have drawn, but it is not a part of a cylinder, it is part of a sphere. That means a sphere is cut and any part of that sphere. So it should look like something like, oh I am sorry, I am so sorry. Okay, this is a part of a sphere. This is your convex or concave mirror depending on which side is the shiny side. Okay, get the point? If this side is the shiny side, it is convex mirror, and if this is the reflecting side, then it is concave mirror. It has to be part of a sphere, all side round, okay, not like cylindrical. Is it clear? Is it clear? Those are cylindrical mirrors, which is not there in course. Cylindrical lenses are also not there in course, okay. They are also in use, but we are not going to study them. So what I am going to make now is, this is part of a sphere, and if I make it like this, it is called a concave mirror. It's like it caves in. If I draw a line which may be passing through the center of curvature. What do you mean by center of curvature? The center of the sphere of which it is a part of. Okay. The distance is radius. This point is center of curvature. Now, somebody try to complete this diagram. I have an object over here. A point object over here. Okay. I have a point object over there. A single point over there. Try to make the image of this thing yourself. Okay. Using the laws of... Okay, now, first of all, I'll make any random ray go from here and strike the mirror. Whether I make a ray strike over there or there or there, anywhere, it is going to produce the image at almost the same point. I make a ray go like this. What will happen to this? It will reflect following the laws of reflection. Any doubt? Now, to follow the law of reflection, first of all, I have to have my normal over here or not? What will be the normal at this point? I'll have to make a 90 degree to this surface. I'll have to make a 90 degree or not? Now you have already done in circles. When you make a 90 degree to the surface, it becomes a radius. Radius is 90 degree to the tangent or not? If this is tangent, then this is the radius. They are 90 degree or not? So one thing what you have to keep in mind always, the normal is the radius of the spherical mirror. All the radii of the spherical mirror are the normals. Wherever you have to create a normal, you don't have to measure a 90 degree in this case. Straight away join the center of curvature to that point in question and you'll get a 90 degree. Why? Because radius is always perpendicular to the tangent at the peripheral point. So I will make the normal. So this orange line must be the normal or not? Now whatever angle it is creating with the orange line, it will reflect back according to the laws of reflection. So same angle and this angle will be equal to that angle. Okay. One ray is done. One ray is done.
Yes.
We need another ray.
Yes.
And where both the rays will meet, that will be the point of formation of image. So the other ray I will make go like this along the principal axis. We call this line as the principal axis. Okay. Why? It's the easiest line to make or not? It will reflect back on the same line or not? Because this is the normal itself. So I'll make it go along the normal and it comes back along the normal. So this goes like this, bounces back like this. Now suppose my eye was over here and my other eye was over here. All the time I'm not going to draw the eye now. Okay. So this I will think it is in this line, that I will think it is in that line. It is actually where the actual image will be formed over here or not. Get the point? Getting the point? Now this image formed is real or virtual? It's real. Actual real rays are meeting. You didn't have to produce anything backwards and where they are not actually meeting, right? So we are seeing that we get a real. Now forming image like this all the time is not possible. Making the same angle and all, it is almost impossible. Okay. So we have we'll be using some techniques to draw the image wherein we will not be required to measure the angle. And so the techniques what we are going to use is derived from the same fact, by the way. The derivation is same, but we are going to use it now, and we'll forget about making angles same. Get the point? Is it clear? It is again not required. Okay. What is required is now going to come. But if you know these things, it will be helpful for later classes, next year, next to next year, or for any basic logical questions. Now suppose there is a center of curvature. Suppose there is a center of curvature. Okay? We define another point which is called focus in such a way that when a ray goes from the focus, strikes the mirror, it comes back parallel to the principal axis. Any doubt? Let me make clear what is principal axis. There is a spherical mirror. There is a center of curvature. Okay. Any line through the center of curvature may be called the principal axis, but most of the time you will make it flat like this. Okay. This is the principal axis. Get the point? A ray going on this line will come back on the same line. Any doubt? Now we are concerned about a point on the principal axis. We have taken such a point such that if a ray goes from this point, hits the mirror, it comes back parallel. Okay, and we call that point as the focus. In other terms, if I make a parallel ray go and hit the mirror, it reflects back through a point on the principal axis, which is called the focus. Conversely, getting the point? Get the point? You know that rays retrace. If I make a ray go like this and it goes like this, then if I make a ray go backward on the same line, it will go back in the same line or not. Same way over here. If it goes like this, it reflects like this. If the ray was coming like this, it will go through the focus. Okay. So focus is concerned with parallel rays, parallel to the principal axis. Okay. Any ray passing through the focus after reflection will become parallel. Any parallel ray will pass after reflection will pass through the focus. Okay. So this we know, this distance we know is the radius of curvature, radius of the thing. What can you say about the focus? Now we use a little approximation over here that you remember. Okay. Later on you will not be using this approximation in higher classes. So there is an approximation over here. What we use is that all these rays, all the ray diagram what we are going to make is very near to this point. This point is called the pole. Okay. If I am going to make ray diagrams which is way away from the pole, then it is not going to follow the rules what we are going to discuss today. Some rules are made which I am going to discuss now, which is based on the assumption that all the objects are very small in front of the mirror and the rays coming from the object is very near to the pole. Basically all angles should be very small. If the angles become large, then the rule what we are going to discuss is not to be followed.
So can you draw the normal to the ray you took from the focus?
Yes, now we are going to do that. Okay. Now, since we have defined something like this, that if a parallel ray comes, it goes through the focus, let us see actually what is happening. If the parallel ray was coming, it doesn't know focus and all, it will just follow the law of reflection, and I'll draw a normal over here. So, normal at the point of incidence. Now, listen carefully. Whenever I say normal, I'll say normal at the point of incidence. Okay. When you say in your definition that normal this and that is in the same plane and all, doesn't mean anything. Normal, the word normal alone doesn't mean anything. There are so many normals all over. Normal at the point of incidence is the normal you are talking about. Okay. Otherwise this is also normal. Normal may be anywhere else also. Now this is the normal. Since the parallel ray is going through the focus, these two, and it follows the law of reflection, these two angles must be same. This is the angle of incidence I and this is the angle of reflection R. Those must be same. Get the point? Now a small approximation we will take. Acha, anybody before me telling you, can you derive how much will be this length? This, look very carefully. This angle is I. Then this angle will be how much? Y. They are alternate angles. Okay, this is not given in your book, so please make this diagram and note it down. Okay, so this one is I and that one is also I or not? Because R is equal to I. This is from the fact that this angle of incidence is equal to angle of reflection, and this is from the fact that they are alternate angles. Hence, this triangle is an isosceles triangle. Hence, this and that sides are equal. Now, when we take rays very close to the mirror, we say, this is the assumption over here, we say that this length is almost equal to that length. Okay, that is the assumption, which is not actually almost equal, but we assume that thing. Okay, so this length is almost equal to that length. Get the point? Therefore, this and this are equal, hence F will be at the middle of the center of curvature and the pole. Look very carefully. If this ray, if this point is not very far from the pole, this length is almost equal to this length or not? And when I go far off, then this length won't be equal to that length. When I am very near to the mirror, see, if I make this and this and this is almost same or not? If I make lengths from here to the mirror or to this part. Okay. So now be very careful. Do not make a very high curvature. Because all your proofs, all your diagrams will be based on the fact that the radius of curvature is very high compared to the size of the object, and the rays will be hitting very near to the pole. Get the point? So now onwards, make your curved mirrors quite flat. Okay? Make your curved mirrors quite flat. Then only it is going to work right. Getting the point? So, now is it clear that your focus will be at R by 2? This length is equal to that length, hence F is equal to R by 2. So what is focus? Anybody? What is focus? A ray travelling parallel to the principal axis on reflection passes through the principal axis at the focus. Okay? At the focus. Getting the point? Now, that is not the complete definition. It passes from the focus, or it may seem to pass from the focus. It either passes from the focus or may seem to pass or come from the focus. Getting the point? Like over here, if I have a parallel ray coming like this, it will reflect which way? Just use your common sense and tell me. Will it come down or go up? It will go up or not? Because the normal over here is what? If I make the radius of curvature, this is the C, this is the normal of, this is the normal at that point of incidence. Okay. Now it will reflect in such a way such that this angle is equal to that angle. Now I am not concerning myself with the angle. Now I know that when it reflects, when a parallel ray reflects, it reflects in such a way such that it either passes through the focus, this is not going to pass through the focus, or it may seem to come from the focus. Okay. So in convex mirror it seems to come from the focus, in concave mirror it actually passes through the focus. Is it clear? Either it may seem to come from the focus or it may pass the focus. Parallel rays are linked to the focus. Focus are linked to parallel rays. Okay? Get the point? Is it clear? For formation of image we will be using this fact again and again. Okay? Like a very simple case. Now since I know this thing, if I have an object over here, a point object over there, I have to form the image for this. Now I will make, two rays are required, one ray I will make go parallel. Why? Because I know that it will pass the midpoint of C and P, which is called focus now, okay, and it will pass through this. I need not make the normal and make the angle this and that. Getting the point? This can be done directly. So one ray which is very helpful for you would be a parallel ray to the principal axis. And you need one more ray or not? You need one more ray or not? So can you tell me a cool ray? Which one will you draw? This is the object. From here it has to originate, man. Very good. Very good. Very good. Okay. Very smart. So look here. Look here. Look here. What they have said is absolutely right. From here I have to make any ray. I can make any ray. But if I make any random ray, I will have to start measuring the angles. Okay. So I will have to use the fact that I know about focus now. So I will make a ray pass through the focus. And I need not make any angles. I know what will happen to this ray. What is the fate of this ray? This ray will reflect as if, it will become parallel after reflection. Any doubt? This ray and that ray are meeting over here. That is I am not going to draw the eye. This eye thinks it is in this line, that eye thinks it is in that line, and hence it feels right. Now one more ray you could have drawn. We have 3-4 rays now without measuring the angles. One more ray. Very good. You can draw one. The easiest one I would prefer always is the normal. Okay. What happens is a ray passing through, suppose mirror is not there. Okay. So, but if it was there, a passing through the center of curvature. This is a normal ray or not to the mirror? If the mirror was there. Okay. So it will come back normally or not? So it will meet exactly, if I make it with scale, it will meet exactly at the same point. Getting the point? So you'll see which one is within the range of the mirror. If this one is going out of the range of the mirror, don't draw this one, make that one. Okay. If that is within, this is the easiest one to draw because only one line you have to draw. So a ray passing through the center of curvature. It originates from here, goes like this, but when it reflects, it passes through the center of curvature. This ray is normal to the mirror or not? Is it normal or not? Why? This is the center of curvature and this becomes the radius. All radius are normal to the mirror or not?
But if you take any other normal as well, like any other radius,
it has to pass through this point. This is the originating point. No other ray will be the normal except for this ray. This is the normal. Any doubt? And one more they give in the books, I don't know why. That is one going to the pole. Okay, so this ray is also going to give me the object or not? I need any two. How many I have got with myself? The coolest one is one passing through the center of curvature. That is one you will try to use always. So, what was I saying? So you have got 4 rays for you. The best one to use is the one passing through the center of curvature. It becomes the normal itself and goes and reflects through the normal. The second one is what? A parallel ray which will pass through the normal. Third one is what? Pass through the focus. Third one is what? Through the focus becomes parallel later on. And the worst one is reflecting from the pole. Okay, forget about that. Okay, get the point? So these 3, any 2 you can use, whichever is most handy. Get the point? Now, can you see that I am always making a point object all the time? Because images are formed of each point. Suppose I am seeing this duster. Image is formed from 2 rays going out from each point. Okay. Now, in your ray diagrams, if you have to form the image of this duster, what you do is you form the top, image of the top, and image of the bottom. Okay, in this chapter you will not be even doing anything for the image of the bottom. Okay, only the top, and it is the image of the bottom is on the principal axis all the time. So you will just make that thing. Getting the point? So actually, now you people may think that you are making the whole object, but you are not making the whole object. You are making just a point. Actually, Rohin, if you have to make the whole object, it is something like this. This is the full object. You make 2 rays for this point, you make 2 rays for that point, you make 2 rays for that point, then you will get this will converge over here, that will converge over there, that will converge over there, and hence you will get the whole image. And I am going to repeat 3 rays we are going to use. One is passing through the center of curvature. The other one is parallel, passing through focus. The third one is passing through focus, becoming parallel. Now you have done away with the angle of incidence and angle of reflection. Okay. Now everybody individually draw. If I have a point object over here, make all the 3 rays. Make C, make F right in the middle of P and C. Make your mirror quite flat and you will get it absolutely right. If you want to be nearer to your answer, make your mirror quite flat. Don't make it this flat, man. It will not even seem like a convex mirror. I have made it flat over here. Little curve. Okay. Yeah, this is convex. This is your C, and this you have to measure properly, and right in the middle you have to put your F. Okay, no guesswork in this. With your scale, whatever your C you have put, like say 6 centimeters, then at 3 centimeters you will put your F. Everybody done making the image? Aditi, done talking? Okay, that's it, man. See, first of all, make the coolest one. What is the coolest one? It should be normal to the mirror. And in curved mirrors, if you want to get a normal one, how do you get a normal one? It should be headed for the center of curvature, right? How do I draw a normal over here? If I am heading for the center of curvature, no matter what, that line would be normal. And my aim was center of curvature. Now obviously the ray is not going to go behind the mirror, right? It will stop over here and reflect. But this was my aim. And what will happen to this ray? Will it reflect right side or left side? It will reflect back on the same line, because this is the absolute normal. Why is it normal? Because it was headed for the center of curvature. Get that one clear in your mind, then others would be quite easy. Okay, so this one reflects back in the same line. Any doubt? The other one, what will you draw?
Parallel, passing through focus, yeah.
So one, I'll draw a parallel. Now what happens to this parallel one? What happens to this? It is somehow linked with the focus. It is not going to pierce the mirror and go back. It is going to reflect. But it reflects in such a way that it is coming from the focus. So you will draw a dotted. It reflects in such a way such that it seems to be coming from the focus. 2 rays are good enough. I can complete my diagram with this, but I will like to draw the third ray also, just for practice sake. Okay. So what is the third one? This ray headed for the focus. Headed for the focus. Okay. Now if it is headed for the focus, it is something like this. Now what is going to happen to this ray?
It's going to be parallel from the pole.
It is going to...
Extend it to the other side.
These are the rays. These are the 3 rays. Now the rays after reflection, I am going to extend back or see whether they are meeting or not. Unfortunately, these rays are not going to meet. So your image is not going to be this side. Your eye is here or here or here or here. Where do they register the image to be at?
Where do they?
I'll make this go back. I'll make this go back. I'll make that go back. All 3 of them, yeah, should meet.
No, they do.
I mean, if you draw it properly, it will. Okay. So this is where the image is. Any doubt? Now tell me what is wrong in this, what she is doing. This length is the center of curvature, that is the radius. So she has made this much. This is the center of curvature over here.
There's no center of curvature outside this.
Yeah, obviously this is not a center of curvature, man. This is not a center. Now If you draw any line like this, is this normal to the mirror? No. Not at all, not at all, not at all. This is normal to the mirror. Through the center of curvature I draw anything, this is normal. This is not, no, that is not normal to any side. All these are normals. Now shall I go on to formation of images? One ray diagram I am going to make. There is one ray diagram for convex mirrors and I think 3 or 4 ray diagrams for concave mirrors. When you are forming images, when you do it, you will see one thing, you will notice one thing, that when the object or the image is near to the mirror, it is small, and when it is found far off, it is big. Okay, we will prove it later on, but to make your diagrams neat, if I give you an object over here, don't make this big object over there. Otherwise, its image is going to become very large if it is going to be formed far off. Okay, get the point? So, when you go nearer to the image, nearer to the mirror, make smaller objects, and when you are far off, when I say that your object is away from C, make this big. Okay, get the point? But when it is here, make this big. When it is here, that make that big. That will make your diagrams neater. So I am going to draw.
So we're doing all the concaves now?
Yeah. One I am going to draw, others you will draw very fast. This one, how to get the image? I want to get the image of the whole body, but if I get for the point A, the tip, that is good enough for me. The rest, the B will be on the principal axis. So how to draw it? Which ray to draw first?
Perpendicular to the principal axis.
Cool ray is going out of range. So I will one parallel. It returns to the focus. The other one passing through the focus. So here is A is formed over here. I'll write it as A dash. If I had taken a C point over here, it would be formed over there. I need not form it, and then the whole object will be formed like this. So it will be inverted, formed from real rays. So it is real and inverted, and we see it is enlarged. Why it is enlarged? It's further away, and you have already done similar triangles. Can anybody tell me? Prove it that it is enlarged. Anybody can prove that this one is bigger?
That's 90, that's 90.
Please.
Parallel.
Say this is your object, and here after doing the focus and parallel rays, I get the image over here, suppose. But one ray which we are not using, which is not useful in making the ray diagram, but anyhow it is there, that when a ray comes to this point at the pole, it will reflect and it will also pass through this point or not. Is that true or not? Now this angle will be equal to that angle because this is the normal itself, the principal axis is normal itself. So this triangle is similar to this triangle, this angle same as that angle, this is 90, that is 90, though both are similar or not? Both are similar or not? That means this height by that height on the top by height on this one, say height of the object divided by height of the image, will be what?
B to that object.
Distance of the object, which is written as U, divided by distance of the image, which is written as V. In fact, this is a formula, okay? HI by HO is equal to V by U. This formula you will be using in this chapter, okay? So there is a very simple derivation for this. So what we see is height of the image divided by height of the object is equal to distance of the image divided by distance of the object using your similar triangles. So this is the formula, and height of the image divided by height of the object is called magnification. If the height of the image is same as height of the object, it is 1 magnified. If height of the image is twice height of the object, it is twice, and if it is half, then it is 0.5. So height of the image divided by height of the object is called magnification. This will be, many questions will be on this, okay? Now there is one more thing over here. you have to be careful with the signs. There is a sign convention. Any height above the axis we take it as positive. Any height below the axis we take it as negative. Okay. All distances left side of the pole we will take it as negative. All distances right side of the pole we will take it as positive. I will repeat this when I am doing questions. So just now, since I have written the formula, this height of the image is actually negative over here. So if it is a minus over here, I get Hi by Ho is minus V by U. The formula is minus V by U. In this case, okay, in mirrors, okay, that is the formula. I'll revisit this formula and we'll discuss the sign convention later on also. Right now, take a 2 minutes break if you want, but I have to complete everything. You have to form the images when case 1, object is here, number 1. Number 2 we have already done. Number 3, say this is number 3. Number 2, object is on the center of curvature. And number 3, this. Number 4, it is between focus and the pole. Number 4. So these 4 images you should know.